video on equivalent fractions. In this video, I'm going to show you what equivalent fractions are and how we can make them and why they're important. Equivalent fractions are fractions that have the same value but have different numbers. So they look different because the numbers are different, but really they're exactly the same. And equivalent fractions are important when we're adding and subtracting fractions or trying to simplify fractions, especially when we have different denominators. Let's look at a few examples. Here I have, in my first example, two fractions, 1/2 and 4/8. 1/2 and 4/8 are equivalent fractions. And again, that means that they have exactly the same value, even though the numbers are different. And if we look at the drawing or model here, we can see why they are the same. For 1/2, you'll notice that the top half is colored in red. And for 4/8, you'll notice that the top half is colored in red. So even though they're broken into smaller pieces in the 4/8 circle, the amount of red, or the amount of the circle colored in red, is exactly the same. It doesn't change from 1/2 to 4/8. And so you can see that the number or the amount that we've taken of the circle is the same. And so therefore 1/2 is equal to 4/8. That makes them equivalent fractions. In our next example, we're going to look at two equivalent fractions as well, 1/3 and 3/9. 1/3 is the same as 3/9. In other words, they have exactly the same value. And if we look at the drawing here, we'll see that the amount colored in green takes up the same area in both of them. Even though the 3/9 is broken up into much smaller pieces, we're taking 3 of those green pieces as opposed to only 1 of the green pieces in 1/3. But again, the amount of area colored in green does not change even though my denominator changed. Therefore, they are equivalent fractions. In the last slide, we talked about 1/2 and 1/3, and in this slide I'm going to show you more about how that works. So here I have 1/2, and you can see the top half of this circle is colored in red. But what happens if I start breaking this circle up? Here you'll notice that I'm breaking it into fourths. Now I've broken it into 2/4, but you'll notice the amount colored in red did not change at all even though I broke it up. And now I'm going to break this up into 4/8. Again, you'll notice that even though I have smaller pieces, and now I have 8 of them, 4 of them are colored in, which makes it the same as 1/2. Over here, let's look at what happens when I break this into 9 equal parts. You'll notice that even though I have smaller divisions though, the amount of green colored in did not change. Therefore, 1/3 and 3/9 are equivalent fractions. Well, how can we make equivalent fractions? Quite simply, we can make equivalent fractions by using something called a multiplier or something called a divisor. It's important that you remember that a multiplier and a divisor does the same thing. They create equivalent fractions. That's it. We're going to start by talking about a multiplier, and it's really important that you remember what a multiplier is because we're going to use it often throughout the year. Any number can be a multiplier as long as it's the same number on the top and the bottom of a fraction. So a multiplier is just a fraction that has the same number as its numerator and denominator. So here's some examples of different multipliers, and I just put these randomly down. We could choose any number as long as it's the same on the top and the bottom, but you'll see I've written 2/2, 3/3, 4/4, 5/5, 9/9, 12/12, 17/17, 21/21. All of those are multipliers, and we could have 1,000/1,000 if we wanted as a multiplier. It does not matter, just so long as the top number and the bottom number are exactly the same. Why is it that it's so important that the top and the bottom number be the same in a multiplier? Well, the reason is because you have to have it equal a value of 1. Now you might say 2/2, does that equal 1? Well, yes, it does. Remember that a fraction is nothing more than a division problem. And if we do the division in all of those multiplier examples I gave you, you'll see that the value equals 1. So 2 divided by 2 has a value of 1. 3 divided by 3 has a value of 1. 4 divided by 4 has a value of 1. And so forth. And so you can see that really when we use a multiplier, we're really multiplying by 1. And when you multiply anything by 1, you get the same value. This is why it's important that you know that a multiplier really equals 1, because that's why the value never changes. You're just simply multiplying by 1. It's just in a different form. So let's make a few equivalent fractions here. Here I have 1/2 and 2/4. 1/2 and 2/4 are equivalent fractions. And we're going to use a multiplier of 2. And again, when you use a multiplier, it has to be the same number on the top as the numerator and on the bottom as the denominator. So if I take 1/2 and multiply it by 2/2, then I get 2/4. So we just made a new fraction, but it has the same value as 1/2. Here I'm taking 1/2, but I'm going to use a multiplier of 5, or 5 over 5. So if I do 1 times 5, that equals 5, and 2 times 5 equals 10. So 5/10 is an equivalent fraction to 1/2. Here we're going to take 3/5 and use a multiplier of 10, one of my favorite multipliers because they're easy, because you just have to add a 0 on the back of each digit. But 3 times 10 is 30 and 5 times 10 is 50. So 30/50 is equivalent to 3/5. In my last example here, we have 3/5, and I'm going to use another easy multiplier that I like to use, which is 11, because you're just doubling the single digit. So 3 times 11 is 33, and 5 times 11 is 55. Once more, 33 and 55 is the same, or it has the exact same value as 3/5, so they're equivalent fractions. One other quick example by using modeling to show you why equivalent fractions stay the same. We start off with 1/2, and again you'll notice in my fraction bar I have 1/2 colored in blue. And then my second fraction I have 2/4, so I've broken the fraction bar now into 4 parts. But I have 2 of them colored in, which equals the same amount as the 1/2. And then finally, I have 5/10 with 10 divisions in the fraction bar, but 5 of them colored in. So you'll notice that for 1/2 I only have 1 section colored in, but it's a large section. In the second example, I have 2 colored in, but it's a little bit smaller. And then finally in 5/10 I have 5 sections colored in, but they're small. Remember that your denominator tells you how many divisions you have, and so the larger the number of the denominator, the smaller the pieces. So I have to have more pieces, 5 in this case, to equal 1 large piece for 1 in 1/2. But still, they have exactly the same value. So let's go over finding some multipliers. Sometimes we have 2 equivalent fractions and we need to figure out what the multiplier is. In this case, they'll give us 2 fractions and we have to figure out, okay, what number would multiply into the other fraction. So how I'm going to do this is I'm going to look at the smaller denominator and ask, can I multiply this by some number that will equal the other denominator? Let's look at an example. So here I have 3/4 and 6/8 as my 2 fractions. And I want to know, can I multiply that for the smaller denominator by some number and have it turn into 8? Well, you can. You can multiply 4 by 2 and have it turn into 8. So 4 multiplied by 2 equals 8, and 3 multiplied by 2 on the top equals 6. So in this case, our multiplier is 2, or 2 over 2. In our last example, we have 5/7 and 15/21. And these are equivalent fractions, but I don't know what the multiplier is. So I'm going to look at the 7 and say, can I multiply the 7 by some number and have it turn into 21? Well, if you multiply 7 by 3, that equals 21. So I've got to multiply the bottom by 3 to get 21, and then I've got to multiply the top by the same number, 3, to get 15. So in this case, my multiplier was 3. Now I want you to try solving a couple problems on your own. So first, you're going to use a multiplier of 3 to make an equivalent fraction to 4/5. Then I want you to find the multiplier for these 2 fractions, 5/8 and 10/16. Pause the video now, solve these 2 problems, and then when you're done, turn the video back on to check your work. Pause the video now. Alright, let's go over the work. In the first problem, you want to use a multiplier of 3 to make an equivalent fraction to 4/5. So if I take 4/5 and multiply it by 3 over 3, remember a multiplier has to have the same number on the top and the bottom, then I get an equivalent fraction of 12/15. 4 times 3 equals 12, and 5 times 3 equals 15. In our second example, we have 2 fractions, 5/8 and 10/16. And I want to find out what the multiplier is. So I'm going to look at the smaller denominator, the 8, and ask myself, what can I multiply 8 by to have it turn into 16? Well, I can do 8 times 2 is 16, so my multiplier is 2. So if I do 5 times 2, that's 10, and that gives me my multiplier of 2 over 2. As I mentioned earlier, sometimes we go in the opposite direction. We go from a larger fraction down to a smaller fraction. When we do this, this is a process called simplification, or we might say we simplify a fraction. But when we simplify a fraction, we need to use something called a divisor. A divisor works exactly the same as a multiplier, except we use division to solve the problem instead of multiplication. Let's look at a few examples. Here I have 10/14, and I'm going to go down to my equivalent fraction of 5/7. But in this case, I'm starting with the larger denominator, 14, And instead of multiplication now I need to divide. So I'm using a divisor rather than a multiplier. So I'm going to ask myself the question, can I divide 14 by some number and have it turn into 7? Well, I can divide 14 by 2 and have it turn into 7. So my divisor in this case is 2. So 10 divided by 2 is 5 and 14 divided by 2 is 7. Now I want you to try it on your own. I have two problems for you to work on. First, I want you to use a divisor of 3 to simplify the fraction 9/12 down to an equivalent fraction. Second, I've given you two fractions, 5/25 and 1/5. I want you to find the divisor that turns 5/25 into 1/5, or that you can simplify 5/25 down into 1/5. Pause the video now, and when you're done, start it again to see if you got the right answer. Alright, for our first problem, we're going to use a divisor of 3 to simplify 9/12. Again, a divisor works exactly like a multiplier, so I need to divide the top and the bottom, the numerator and the denominator, by the same number, which is 3. So 9 divided by 3 is 3, and 12 divided by 3 is 4. So we come up with an equivalent fraction of 3/4. For our second problem, we already have our two fractions. We have 5/25 and 1/5, and I need to figure out what my multiplier would be. So I'm going to look at 25 and say, can I divide that by something and have it turn into 5? Well, I can divide 25 by 5, and that equals 5. So I found my divisor is 5, or 5/5, because 5 divided by 5 equals 1, and 25 divided by 5 equals 5. Finally, a few things I want you to remember from this video. First, equivalent fractions are fractions that have exactly the same value, but they just have different numbers. Second, you can use multipliers or divisors to create equivalent fractions. Third, the multipliers and divisors are fractions that have the same number as the numerator and the denominator. So the same number on the top and on the bottom. And finally, and maybe most important, is that multipliers and divisors have a value of 1. This is why fractions are equal when you use them, because we're either multiplying by 1 or dividing by 1. And either way, we get the exact same value.